In this video, we're going to talk about occurrence data structure. So this would be the part 4 video of the Adam training. So myself, Ali Sheikh, I am the consultant at Trial Optima. Okay, let's continue with this one. So in this content of this training module will be on the occurrence data structure. So the content basically provides the part of Adam model and Adam implementation guideline. But the main focus of the new Adam occurrence data version 1.0, so which covers the material in depth. So it is recommended to reference the following material. So the following material for the training session. So the please open. So this referred understanding the purpose of the occurrence data structures. So here what we have, so basically it requires like for the understanding the reference materials, there is different versions are available. So the current version is version 2.1 and the Adam IG is 1.1, occurrence data structure 1.0. Okay, so the series Adam terminology and the module objectives are basically to understand the purpose of the occurrence data structures and identify the key variables in occurrence data structures. So it reviews the review the practical examples of the implementation and what are the apply occurrence data structure principles to the clinical data programming. Okay, let's continue with this one. Okay, so what is occurrence data Adam data sets? So definition, purpose. So in this part we will go doing this all these parts, all this table of content. So first, what is occurrence data structures and occurrence data structure variables? What are the key variables and their requirements and what are their implementation details. Next we will be understanding what is the conclude, like the final thoughts of these particular occurrence data structures. So occurrence data structure, so what is that one? So here this is a specialized Adam data set. So it's designed to represent the clinical events that can occur multiple times for a subject during a study. So some common examples are adverse events, medical history, concomitant medications, and the protocol deviations. So the basically, if we have, if any subject have multiple events, clinical events happen for during the study, so those data structures will be considered as occurrence data structures. So adverse events, the medical history, concomitant medication, and the protocol deviations. Okay, so the occurrence structures and purpose. So source data. The source data are typically derived from the SDTM domains like AE, CM, MH, and DV. Then apply analysis flags the transformation, the categorizations, and derivation while preserving the occurrence structure. And the analysis ready enables direct analysis of occurrence data without. Okay, so the analysis ready. So here the transformation. So the basic the source data will be the SDTM dataset, then we'll be applying some transformations, then it will be ready for the analysis. So occurrence data structures maintains one-to-one relationship with the source records while adding analysis variables that facilitate statistical analysis and reporting of occurrence data. Okay, so this is an example of occurrence data structure, simple example. So occurrence data typically takes a format of originating the SDTM dataset. So therefore, the following the same structure of SDTM dataset itself. Therefore, occurrence data structure dataset is generally contains one record per original record, the corresponding SDTM domain. However, depending on how the events of analysis set up the SAP, there could be reason display records based on the certain coding path of analysis phase period. Therefore, it is important to be aware of all event analysis in the study before beginning the setup of occurrence data structure specifications. So this is, we can see that many of the variables have covered SDTM. So here it's use subject AE termed AD code AE, so ACRS. Most of them are coming from the SDTM. So the treatment emergent flag, we'll be going into more depth, so this is, this is also coming from the SDTM level. So difference between the BDS and occurrence data structures. The BDS is analysis parameter based, often time oriented. It is one record per parameter per time point and uses param CD, aval and aval C. So the examples are ADLB, ADVS, ADAG, EG. So occurrence data structures is event-based data structures. So preserve one-to-one SDTM matching. So it the structure of the SDTM will be the same in the occurrence data structures, and there won't be having any parameter level structure here. And the focus on the categorization variables ADAE, ADCM, ADMH. Okay, so the occurrence data structure variables will be having identifier variables, basically the common variables, study ID, unique subject ID, and the sequence required for all occurrence data sets. And the topic variables that describe the specific occurrence events. So the term, decode, cat, and subcategories often preserved from the SDTM. And the timing variables that captures when events occur, SDT, end date, analysis start date, like study date, analysis end date, relative to the reference periods. And the analysis variables that support statistical analysis and reporting. So they will be having the flags and categories and the derived classification variables. Okay, so ADSL and identifier variables. These core variables are established. So the ADSL, so these core variables establish the foundation of every occurrence data set. So the variable name, the variable label. So here these are the identifier variables. So these are the required variables of every occurrence data structures. So ADSL variables should be merged into all occurrence data sets to support analysis by treatment groups, demographic factors, and other subject level characteristics. Okay. So the dictionary coding and categorization variables. So the category, subcategory, analysis category. So will be these are the permissible variables, permissible core variables. And SDTM variable is cat copied directly, SDTM variable subcategory copied directly, and category for analysis. So we'll be having medical coding dictionary. Okay. So the next one is the dictionary coding variables for adverse events. So when we're looking specifically at the AE domain, the MEDRA dictionary is an order to code these adverse events, right? As a result, there are several variables that are designated to store the MEDRA informations. The hyphen term is a verbatim description of the event as reported. This is uncoded variables and usually comes directly to the investigator to describe what the adverse event was, and this term then goes through the is coded up in order to provide a standard analysis across all adverse events. And the decode bodices and the LLT high level term, lowest level term, and high level group term, and the SOC, the primary system organ class. So all these variables are related to the various levels of coding hierarchy. For example, HLT provides high level of coding of the event, then goes down to the lowest level term. So each of them times tend to have numeric coding variables that also supply to the dictionary coding. So these variables are enable standardized classification of adverse events and medical history for consistent analysis across the clinical studies. So these variables standardize concomitant medication data across the studies, enabling the consistent medication naming and classification, hierarchical classification using ATS coding systems, and multiple medication categorization levels, and cross-study comparison and pooled analysis. All variables come directly from SDTM and are derived from the standardized dictionaries. So you can see these are the concomitant medications. So basically these are coming from this hierarchy will be coming from the WHO, World Health Organization. Okay, so the next continue with this dictionary coding in practice. So here we have the primary variables. The A term captures the verbatim description, while A decode standardized to the meta preferred term. So the AE verbatim term currently stored in AE term. So this comes directly from the CRF. So here the AE decode variables obtained from the meta dictionary information. This is equivalent to the preferred term. Used the main primary analysis variable for the individual records within the analysis. And this classification variable, so the body AE bodices variable, that displays the system organ class for the AE decode variables again, and this is assigned MEDRA additional coding mapping. Okay, so and the AE SACD has been included in here too. So to show the numeric coding variables, AE bodices and the AE SOCs. So this direct coding for the text variable providing in AE bodices. So the common patterns note how similar verbatim terms, diarrhea and the area map to the same standardized term. Okay, next, So the timing variables for the analysis, the timing variables, so you see the duration hyphen duration permissible variables and analysis duration, the numeric format analysis duration units. So the timing variables are created using two dates collected in SDTM. So analysis dates and times are set up as needed. So they follow the same rules in as the BDS timing variables. Okay. Okay, so next one is indicator variables. So indicators, so there are certain types of indicator variables needed for occurrence data structures. So some can be used in BDS while others are specific to the occurrence data seen in occurrence data structure. There are specific indicator variables for AE and CM as well as the variables for other types of both types of data. So XX occur or PRSCP variables comes directly from the SDTM domains and get used if there were pre-specified adverse event being looked for. Okay, the hyphen occur variables as a flag variable. Okay, the flag variable that denotes whether or not to give an adverse event occurred in the analysis. A generic variable that can be used in the occurrence data structures is analysis ZIF 01 flag. 01 Z means 01 or 02. So use it to select a specific record for analysis based on predefined criteria. It provides the flexibility for creating analysis dataset with precise record selections. Okay, so the next one will be the temporal indicators. So the treatment emergent flag of analysis for analysis and on treatment flag record flag and pre-treatment flag and follow-up flag. So the treatment emergent flag is defined for the variable for analysis. It can be created in the SDTM level to provide the traceability, but for analysis needs, treatment emergence should be rederived added into the treatment emergent flag. So treatment emergent flag is used in AE and therefore the on treatment flag not needed. On treatment is flag is specific to CM data and has similar purpose to define on treatment medication use. Okay. So these variables categorize occurrence AE and concomitant indicator variables. So here these variables categorize occurrences based on their temporal relationship to the treatment. So the before treatment started, during active treatment, after ended the treatment, and the treatment emergent events. So all are conditional core variables, meaning they are required when relevant to the analysis. Okay, so these are the indicator variables in practice. So although so we'll be having so this is some example showing some in temporal indicator flags are applied in adverse events. So the treatment period you see the 2019 to 05 April 2019. So and event date is 27 Feb 20. So before the treatment has happened, that we have applied the treatment flag. And if it is so this is starting cystis because it is happened this event was happened during that start of the treatment period, and then we give us treatment emergent flag equal to y. And the dermatitis is so this event has happened after the finishing the treatment, so this could be the follow-up flag. You see the 005 here, and the event date is 07. There is so after the treatment is done. So this event has happened after the treatment, so then we have to give as a follow-up. These flags are enable focus analysis of events with a specific temporal relationship to the treatment administration. So the next one is the occurrence flag variables. So there are some subject level occurrence flag. So although occurrence flags are user defined, so there are some common flags defined occurrence IG, occurrence data structure IG that can be used in order to set up the occurrence flag. So all flags are described follow y or null. Okay. So the populations, the common variables to use when setting up the occurrence preferred term and the system organ class. Usually these flags are set up sorting by the setting by the given variables of interest. The first variable per criteria is then flag. For example, AO first occurrence of the specific preferred term variable, the sort order would be subject number. So followed by the preferred term variable. Okay, so there are some severity based flags. So the first occurrence of the maximum severity and first maximum severity within preferred term and first maximum severity within SOC. So all occurrence flags variables are permissible core variables and can be customized with for uh, for the period of flags for study specific requirements. So the key applications, the occurrence flags enables sophisticated analysis, subject incidence tables by event time, first occurrence analysis by body system, maximum severity reporting, time to first occurrence analysis, Kaplan Meier estimation for events. So these flags are essential for regulatory submissions and safety signal detection across the clinical development programs. Okay, so the next one will be the treatment and dose variables. So the treatment dose on record starts. The numeric variables displaying the dose of the study treatment that the patient was on a start of observation. So the core classification is permissible. And the cumulative actual treatment dose is the numeric variables representing the total amount of the study drug received at the start of observations. And the units, the character variables specifying the units of those ON and those CUMA if they are displayed. Okay, so any treatment variables that are used for analysis of occurrence must be included within the data set of interest. Okay, so this could be either TRTA or TRTP, TRT01P and TRT01A defined in ADSL. It may be useful to know for analysis proper what dose of the patient was on at a given time when record of interest started, or the total dose received at the point of the occurrence started. Okay, so these variables are essential for tracking the patient exposure to investigational product and establishing the dose response relationship in oncology trials. So the descriptive variables, ADAE derived variables. The ADAE analysis dataset adverse events contain the derived variables that enable standardized analysis of the safety data across the studies. So they have some severity variables, analysis, severity in the numeric format, and the severity groups, the casualty variables, relative analysis, relative numeric format, and the toxicity grade variables. So what is the difference between when you ask what is the difference in between the oncological studies and non-oncological studies? So there will be the difference only when you come to the severity. So this is irrespective of the adverse events. So there it is having in oncology will be having the toxic grades like the mild, moderate, severe, life threatening and death, while as a non-oncology study you will be having only mild, moderate and severity. So these are the difference you can see able to see from the adverse events. Okay, so here will be this example demonstrates how raw AE severity data is transferred into the analysis variables. So you can see the headache, the AE severity, which is the moderate, and the analysis severity will be the moderate, and the numeric format will be given as a 2, and the group will be the minor group, and the group in the numeric format will be the N. And if it is the sinus pain that is severe, somehow is missing. So so we are, because this is missing, we are imputed as a severe, and then the grade will be the given as a 3, and the group will be the major group, and the group in the numeric form will be the 2. Okay, so the missing severities are imputed as a severe based on the predefined rules. So the numeric values are assigned to facilitate statistical analysis, and grouping variables created for the analysis, pooled analysis, severity groups and group numeric format. Okay, so the next we so next will be the subject standardized Medra query, standardized Medra query SMQ variables. Okay, so the SMQ is are increasingly common in analysis in order to identify the safety issues with the experimental compounds. The standardized or customized queries can be created in order to specific records to cover required information. Example, area of special interest to the particular protocol. Okay, so these variables facilitate the standard safety signal detection across the study using the MEDRA terminology. Custom queries can be implemented for study specific requirement not covered by the standard SMQ. So this is a specific term used part of the SMQ analysis. So yeah, these are permissible variables mostly. So the variable implementation best practice, so the data integrity, maintain consistent naming conventions across the studies and document imputation rules for missing data, and validate derived variables against source data, ensure traceability between raw and analysis datasets, and the programming efficiency, create a reusable macro libraries for variable derivations, implement automated QC checks for variable consistency, document mapping logic between the raw and derived variables, build the standardized templates for common oncology analysis. So these are some best practice of the variable implementations. So the implementation considerations, so you should have to go understand the protocol, thoroughly review the protocol requirements to identify the study specific variable needed beyond the occurrence data structure standards, document any protocol specific derivations, and the SAP alignment. Ensure statistical analysis plan specification align with occurrence data structures, so variable definitions resolve any discrepancies before dataset creations. And there should be a version control, maintain the clear documentation in which occurrence data structure version is being implemented, and track any modifications to standard definition. And cross-function collaboration, coordinate with the biostatistician, medical monitors, and data management to ensure the variables meet analytical needs. So the final thoughts, the consistent implementation of occurrence data structure variable is in the foundation of for efficient across study analysis and regulatory submission in oncology clinical trials. The standardized approach enables faster database lock and analysis timelines, more efficient regulatory submissions, improved data quality through consistent definitions, and enhanced ability to perform integrated analysis. Okay, so yeah, so this is the occurrence data structures. So that's it for this video. We'll continue for the next classes. Thank you for watching.